Well, hello, C++ programmers. Brian Malloy here, and I wanted to talk about constructors. Actually, not constructors, but functions, member functions that C++ silently makes for us, or generates for us, if we don't write them. Now, it's not so relevant to the class that you see in front of you. This is the one I did in the previous video. Excuse me, Class A. Why is it not relevant to Class A? Well, the only data attribute it has is an int. And ints don't suffer from the difficulties that inherent in shallow copy versus deep copy. And that is what it's the root of this problem, shallow copy versus deep copy. And when you have primitive types like ints and floats, you always get a deep copy. It doesn't matter. The problem develops when you have pointer variables. So if you are a little confused about what's going on here, I'd watch the previous video on constructors, C++ constructors. What I want to do now is move on to what I'm going to call canonical form. So what does that mean? Well, in that case, we want a class, and I'm going to use a string class just because it's kind of a canonical example. It's a class with a pointer variable, heap-based memory. So that changes the complexion of everything we're going to do. Now we have a data attribute of the class that's not a primitive type like int or float. We have a pointer. And as soon as you have a pointer, you're talking about a whole new ball of wax. And I think you realize that. Most people realize that as soon as they get into pointers, the intricacy increases quite a bit. So what does that mean? Well, I thought I'd write some constructors and show you that C++ does generate some functions for you if you don't generate them. So, for example, let's go ahead and show you that this compiles. I do get a warning because I'm not using this data attribute, but that's okay. And we compile it and run it, and it prints hello. Okay, so it's a syntactically correct program, though it doesn't do much, and it's kind of sad. Okay, so let's write a couple of constructors. Let's write first a default constructor. We learned what that was last time, and so we're going to use initialization rather than assignment and create a character of size 1, and then we'll just stick a null byte in it. Okay, so there we have it. Let me just go ahead and write these. Const char star b strlen b plus 1. That looks right. And then what we want to do here is strcpy into buff from b, and we're done. Okay, so what have I done? I've created a default constructor, and I've created a conversion constructor. Cool. And it's not going to compile because I'm using this little strlen, which is in a library. Which library? It's in CString. CString is like string.h if you ever happen to use a C compiler, and I don't think anybody does that anymore. I don't even know if there are any. But if you had one, it would be equivalent to good old string.h for C compilers. So we have the default constructor, and we have an initialization list that starts here and ends right there. And we only have one data attribute to initialize, buff, and what we initialize it to is a buffer of size 1, and then we stick the null byte in there, which means I can go ahead and create an instance of string. Let's call it A, and I could actually print A if I had a get buff or an overloaded output operator. Let's write a get buff next. And here I have a C string I'm going to pass in here, and I'm going to create a wrapper around this C string that will encapsulate our notion of what a string really is. And so let's see, what do I want to do next? So I have string, char_b, I create room for it. It's the length of whatever C string I pass in, plus 1 for the null byte, because strlen doesn't count the null byte when it finds the length here. Excuse me. And then I copy from what I passed in B into the buffer that I've created here. And now we want to write a get buff, so that'll be const char star get buff, and it's a const function, and we'll return buff. Okay, so what have I got here? I've got a getter, basically a getter. And I put const here because when I return buff back here to the main program, I don't want someone to modify it. If I pass a pointer to this data attribute in here, and I don't pass it as a const, then someone here could change it without going through my public interface, which I do not want. That's bad, very bad. If I pass it back as a const, that means it has to stay const when it gets back here, and I'm good to go. And this const right here indicates that this function will not modify any of the data attributes of the class because it's a const function. What are the data attributes of this class? Buff. And this says it's not going to modify them, and you can see it returns it without modifying it. So I'm all set to go. This should go ahead and compile. Let me make sure I saved it. Then let me get it out of the way. Compile it. It doesn't compile. What? Expression which evaluates the zero treated warning. Expression buff. Oh yes, I see the problem. Okay, we just want to stick it in buff of 0 there. How's that? Better? Oh, now you're happy with me. Good. Okay, it's happy with us. Let's see what we've got. Oh, wait. Well, let's go ahead and run it. We run it and we get nothing because we just stuck the null byte in there and we got the end of line here. Okay, good. How about the conversion constructor? Let's write a conversion constructor. Oh, doggone. Let's do it this way. B cat, and now it's kind of boring to print A. Let's print B. So let's get this out of the way, and let's clear the screen, make it, run it, and we get cat. Okay, cool. Now we know how to overload the output operator because we did that in the previous video. So let's go ahead and do that and get out of the way. So we want to pass OStream, and we want to overload this guy. And we want std OStream. We want to pass it by reference because we're going to stick something in it. And we want to pass our string in here by constref because we're not going to change it. Okay, so what we want to do is we want to return. Well, first we want to stick something in our output stream, namely s.get buff. So what am I doing here? Let me just finish this off. Okay, what am I going to do? I'm saying, okay, this is my output stream. Insert into my output stream the buffer, the char star, and return it, and cout is how to print a char star, so we're good to go. Looks good. So this is our, we overloaded the output operator here. I talked about that previously. If you have any questions, ask me and I'll answer them. Okay, let me just go ahead and run this. This should work. Okay, it does. Looks like it works. Okay, so you might be thinking, oh, that's nice. We actually wrote a nice little string encapsulation. Yeah, except it's garbage. This is disgusting. This is terrible. I mean, why? Well, let me just give you an example. Let's suppose I say C. I'll write it the way you might be used to it. Let's use. Let's instantiate a string object. Call it C. And let's stick a B, use B to make it. This is actually a call to a copy constructor, as you well know. Okay, let's save this. And what's going to happen, you'll see what a garbage class this is. So let me just go ahead, clear the screen, compile it. Warning, unused variable C. Oh, just for good luck, let's use it. Okay, we got rid of the warning. Warnings are scary. Clear the screen, compile it, run it, and we get that. Okay, so you think this is a good class still? No, let's run valgrind. Let's valgrind it. If we run valgrind, we see, whoa, 5 bytes we're leaking. We're leaking 5 bytes. How come? Let me count them for you. Well, A, we make a new 1 byte, so that's 1. B is cat, that's 4 bytes. Count them, 1, 2, 3, and the null byte, right? Plus the null byte. So that's 4. 4 and 1 on Earth gives you 5. Now, what's happening here? There's where it gets interesting, right? Okay, so let's not talk about it for a moment. We'll come right back to that. But we see that we have memory leaks. How do we get rid of these memory leaks? No problem. We write a destructor. Let's write it. So destructor, and we want to delete the buff array, and it is array, so we're announcing. Okay, our destructor says, what does it say? Okay, tilde means it's the destructor. And we want to delete buff, except buff is really an array. It's an array of char. So we have to tell the compiler it's array so it doesn't just try to delete this thing, we want to delete what this thing points to, which is an array. So that should be good. We should have no leaks. Watch, we won't have any leaks now. Let me compile it. Wait a minute. Didn't I just change it? Did I change it? I wrote a destructor. Why does it not compile? Let me try that again. Make it. That's more like it. I hadn't saved it, I guess. And now we run it. Whoa, look at this. We get cat twice, so this works. B has cat in it, and C has cat in it. So, what does that mean? But we get this double free error. Now, how could that be happening? Well, here's how it happens. Okay, double free. Because we made a copy. This is actually the copy constructor. So I'm using a copy constructor right here. Where is the copy constructor? There ain't none. There is no copy constructor here. The compiler says this turkey didn't write a copy constructor. Well, okay, he probably doesn't know how I'll write one for him or her. And so it writes one, but it makes a shallow copy. Gee, how can I draw this for you? Let me try to draw it. This is going to be pitiful. Okay, let me use dia. I'm going to try to draw this for you. So here's a little drawing diagram. So what have we got? Let's go to UML. Okay, we got a class, right? Is this going to work? Oh, no, let me get rid of this. Delete it. Okay, delete. Let me just get a square. Okay, so I've got a square. Oh, it's not a square. What the heck? Let me delete that. Let me get a square. Okay, I got a square. Okay, now this is going to be, I'm going to just skip talking about, you can't see this, can you? Okay, I'm going to draw what B looks like. So this is an object, B. I'm going to draw object B right now. Okay, so what does it look like? Well, let's put a B here. Okay, there's B, right? That's pretty small. Let me make it bigger. Why does it make it so small? Okay, let me make it bigger. I'll make it, stop. So let me make it, 35. Good enough. I don't even want to look. Okay, there's B. Okay, and then we have a buff. Okay, so let me here's buff. Okay, and let me come back here and show you what we had. So we had B, and we use the conversion constructor right here, and we create something for buff to point to. Okay, so we need buff to point to something. It's going to point to a buffer like this that has, this is so hard to do with dia. Okay, so it has 4 bytes in it. B, wait a minute, what is it doing? B, U, F, null byte. Okay, so that's what we've got. All right, you can't see it very well. So imagine 4 cells here. 1, 2, 3, 4. In the first cell, there's a B, and the second cell is a U, an F, and then the null byte. 4 bytes. Okay, count. 4 bytes. And this points to it. So now let's get an arrow here. Okay, we've got an arrow here. Oh, close enough. An arrow there. Let me try. Actually, that's what I wanted to do. Stop it. Oh, man, quit snapping here. Quit aligning. What's aligning? What is it doing? Oh, I'm sorry. View? It's probably view. Oh, it's view. It's doing snap to grid. It's not snapping objects. We don't want them to snap. So I want it to go like that. Okay, there's what I've got. So that's B. Let me show you. So B looks like that. So here's B. I create a buffer room with 4 bytes, and so B. Now I'm going to make C. C is a copy of B. And so we use the default copy constructor, but there isn't one. So the compiler writes one, and here's what it does. Okay, it does this. Let me just copy this. Control CV, and now I'll move it down here. Okay, so let me just change it. Okay, wait. Okay, so let me get rid of this. Delete. Let me say here, Control CV, and make that be a C. Okay, good enough. And bring that down here. Okay, so what does C look like? C looks like this. It has buff, as before, but it does this. Now, why does it do that? What happens? Well, the default constructor says, well, this is an address. I'll just copy that address into this variable. So this is a variable called buff with an address. What address? The address of this 4-byte thing on the heap. And so what it's doing here then is, let me just, I just want to move this a little so it makes sure it looks like, and so it just copies the address in there. So they're both pointing there. So what does that mean? Okay, so let me see if can I fit all this on there? Yeah, I'm going to fit everything on here. Can you see all that? Okay, so what happens? We make an A, no problem. That's not a problem. We make a B, and B looks like this. We use the default constructor to make a C, and it looks like that. So it's okay because I print B.getBuff and I get cat, C.getBuff and I get cat. But then I go here, and what happens? Well, the compiler is automatically going to delete. First it deletes C. What does that mean? Well, it calls our destructor. There's my destructor, and it deletes buff. Okay, when I do that, this happens. Watch. I'm going to delete it. Gone. Okay, so it deletes it. Then it tries to call the destructor for B. When it calls the destructor for B, it comes up here to try to delete buff, but there's no buff to delete. So it's a double free. That's why we get that error, double free. Is it still there? There it is, double free, right in front of us. So we get a double free because we made a shallow copy. Okay, so that's the problem here. And so at that point, if you try to delete memory that's already been deleted, the C++ standard says that behavior is undefined. So fortunately for us, our compiler, we're using Clang, and G++ would have done the same thing, gave us a double free error. On this system, it's possible that on another system it wouldn't even do anything. It might not give us an error, but yet we would be having a problem, wouldn't we? Okay, so how do we fix this? I'm going to move this over here and bring this back, and we fix it by making our own copy constructor. Okay, so let me just get a head start here. Never do this. This is called cutting and pasting. Very error prone. Let me see if I can do this. Buff. Okay. There. Okay, is that right? So we pass it by const ref. That means we don't make a copy. We don't pass by value because that would be a copy constructor. We pass by reference, but we keep it const, so it's safe. Then we create a buffer of size, whatever buff is. And notice I can access the private data area of another class if it's the same class as me. I don't have to do a get buff. I can access the private data attributes of a class if it's the same type as me, and this is a string, I'm a string, this is a string, I can do it. I add one for the null byte because string lane doesn't count the null byte. Copy it in. I should be good to go. So let me what's going on? Oh, I got dia going. I forgot. Let me leave dia going there because I might want to come back to it. Okay, so let me compile it and run it. Notice we get our output. And we get no double free because now we've made a deep copy. Okay, I wish I could. Let me just bring that back. What we have now is this. Okay, let me just copy this. What we have now is that, and we do. Oh, stop it. Let's do that, and we do that. Okay, so that's what we've got now. We've got B has its own little buff and C has its buff. How do I know I made it? Where did I make it? Right there for the copy constructor. Okay, so now we don't get a double free. We delete what the buff in C points to. We delete what the buff in B points to, and we're only doing each one once. We're good to go. Okay, so there we have it. Let me get this out of the way again, and okay, so you might think, wow, that's great. This class is in good shape, and the answer is it's not. It's still a crappy class. Trust me on this. How do I know? Well, let's do this. Let's just say C equals A, just for the fun of it, and now we'll compile it. Compile's great. Execute. What? Why didn't I get it? What did I do wrong? C equals A. Why don't I get a double free? Did I not save this? Let me try again. Let me save it, run it. Why am I not getting a double free? I should get a double free. Why? Because did I do something wrong? C equals A. Because I delete A, I use my default assignment operator. This might be one of those cases where the behavior is undefined, but I don't get an error message. I'm not sure. Let me also say, just for the fun of it, because I'm trying to get it to happen, let me say C equals B. Let me see if I get it now. I did get a double free. I'm so grateful. Okay, so maybe there's something, I'll have to think about it, but maybe I don't want to even do that line. Maybe this line will do it for me. And if we think about it, we'll probably say, yeah, there's my double free. See, this is still a crappy class. Why? Because I've still got a shallow copy going on. Okay, so how do we fix this? we write an assignment operator because this class has a pointer variable. When you have a pointer variable, you have to put the string in what's called canonical form. It was called that by James Copeland in a really nice book he wrote. If you have a pointer variable, you need a copy constructor, a destructor, and you need to overload assignment. Too long for one video. We'll overload assignment in the next, and in the next video I'll also talk about the fact that this is not just a concept we must be guard against in C++. It happens in all languages, including Java, Python. You might be thinking, oh, I don't have to worry about memory management. I'm going to use Java or I'm going to use Python. Wrong. Guess again. Shallow versus deep copy pertains to all programming languages, and I'll prove it to you next time in the next video. So until then, happy programming. Brian Malloy, over and out.